Assalamualaikum and hi Doctor. My name is Nur Atika Fatini Muhammad Zaini, ED2476A. For this video, I'm going to share with you about the contribution of fertilizer to river pollution in Malaysia. This video consists of 3 parts. Firstly, the introduction. In this part, I'm sharing with you possible sources of fertilizer and a list of study areas. Secondly, research finding. For this part, I'm sharing with you the summarization of the concentration of nutrients from the fertilizer used in 5 study areas. And the last part is about the impacts of fertilizer on water. Here, I'm sharing the impacts of excess nutrients from fertilizer to aquatic ecosystem and human. Without further delay, let's proceed to the introduction. Agriculture is well known as one of the important sectors in Malaysia's economy. Most of the farmers apply chemical fertilizer for the growth of the crops. And the big 3 primary nutrients in commercial fertilizer are nitrogen, phosphorus and potassium. However, the excess nutrients may leach into the river. This condition gives negative impact on river water quality. So, in this case study, 5 study areas analyzed to study the contribution of fertilizer to water pollution in Malaysia. Firstly, Kuala Gula Bird Sanctuary, Perak. For your information, during the annual migration, Kuala Gula serves as a stopover site for migratory shorebirds, as it is the main migratory routes between Asia and Australasia. In 1986, William mentioned the elevated levels of ammonia, nitrates, and phosphorus in the surface water might affect the migratory birds. Secondly, Rajang River, Sarawak. The source of Rajang River is Iran Mountain. The researcher marked a total of 12 stations along the river for this study. Thirdly, Merbok River, Kedah. The source of Merbok River is Mount Jerai. Fourthly, Raya River. Raya River is one of the main tributaries of Kinta River. Lastly, Padang Terap River, Kedah. For this study area, the high nutrient content in the river may be due to the use of artificial fertilizer to the paddy and rubber tree plants. Now, let's proceed to the research finding. Here is the concentration of TAN stands for ammonia nitrogen and SRP stand for soluble reactive phosphorus for study area 1 and 2. Next is the concentration of nitrate and phosphate for study area 3, 4 and 5. Let's go to the other slide for a clear vision of nutrients concentration comparison among study areas. From the graph, we can see that both TAN and SRP of study area 2 is higher than TAN and SRP of study area 1. All the concentration exceed the reference limit except for concentration of TAN in study area 1. In 2010, Ling mentioned the high phosphorus of study area 2 might due to domestic wastewater discharge. Indeed, the use of fertilizer for paddy field and oil palm plantation at the river. Here, the graph shows the nitrate concentration of study area 5 is higher than study area 4. Despite that, nitrate concentration for study area 4 and study area 5 exceed reference limit of 5 mg per L for Water Pollution Control Statement of Regulation WPCSR. For study area 4, the palm oil plantation near the river utilize a high amount of nitrate and phosphate-based fertilizer to feed the crops. However, the nutrient might run off and leach to river, especially when raining. This last graph shows the phosphate concentration of study area 3 is the highest among the 3 study areas. The results may affect by the use of various fertilizer to reclaim and increase yield due to the frequent agriculture practice near the river. Therefore, there is an abundance of excess nutrient like phosphorus in the river. The concentration of study area 3 exceed the reference limit, while study area 4 and study area 5 are not. Referring to the research findings, most of the concentration of nutrients, methane, SRP, nitrate and phosphate exceeds the reference limit. This indicates the agricultural use of fertilizer responsible for water pollution in Malaysia. So now, we reach at the last part of this video. I'm sharing to you 3 impacts of fertilizer. Firstly, initiation of eutrophication happens when the concentration of the nutrients suppress the critical levels. This situation leads to an increase of algal biomass and shortage of dissolved oxygen. Secondly, the intake of a high amount of nitrate through drinking water may expose to cancer-causing agents known as N-nitroso-carcinogens, which cause lymphatic cancer. Thirdly, infants who drink water contains a high level of nitrate or food prepared by using the nitrate poisoning water might develop a severe disease called blue baby. Nitrate that has been consumed by the infant may react directly with hemoglobin in human blood to produce methemoglobin. The methemoglobin destroys the ability of blood cells to transport oxygen. This condition severe to babies under 3 months of age. With that, that's all from me. Bye!